Hello everyone, I am Venugopal. Today I am going to take a session on artificial intelligence. Artificial intelligence, according to the father of artificial intelligence, John McCarthy, it is defined as the science and engineering of making intelligent machines, especially intelligent computer programs. So, this official definition is given, but we can say AI in a single word that we are making machines that can think and act. So, when we are building a intelligent machines, we have to take care of four aspects. Machines should think like humans, they should think rationally, they should act like humanly, and they should act rationally. So, before building up any AI intelligent computer application, we have to take care of these four aspects. First aspect, thinking humanly, means your machines are thinking like humans. So, humans generally they learn, they apply the logic, they apply the reasoning. So, these three things, and they sometimes humans they take the decisions. All these capabilities a intelligent machine also, if it wants to take then we say they are thinking like humanly. So, if we saw if something if you have a sufficient precise theory, and we can express it as a computer program, means these four things like learning, using logic, reasoning, decision making. If we tell them in a specific sufficient precise theory, we can convert into a computer program. So, thinking humanly basically focus on cognitive skills of a human being, cognitive science of a human, how they think. That is the main procedure we have to think. So, these programs always follow the thought procedure of a humans. Second, machines they should think rationally. Rational thinking means thinking in a right way or right thinking. So, right thinking means if something, it says that if something is true, it should always be true or it cannot be false. How it is possible? When we have a sufficient number of premises and yielding a correct conclusion from those premises, you can give a right thinking. But it is always not possible to go for a 100% knowledge and a sufficient number of premises and making correct conclusions. So, your machines has to overcome this problem. Next one, machines they should act like humanly. Acting like humans means we should not distinguish between a machine and human. Alan Turing test proposed one test where one interrogator, one human and one computer, a computer program, that is intelligent program, they are in a room and he gives one text conversation to a machine and one human. Parallelly he makes the conversation with both of them and he asks some questions. His goal is to identify who is the machine. And similarly, simultaneously, your machine also has its own goal that I should convince interrogator that I am not a machine, I am a human. So, if machine succeed in this goal, then we can say that that machine is an intelligent machine. That is proposed by Alan Turing during early days of artificial intelligence. So, means here basically we should not distinguish between a machine and human. Coming to our topic, subareas of AI. So, I told you what is AI and how machines, intelligent machines, how they are developed using those four aspects. Next, AI is made up with different subareas. So, it is not a single subject, it is an umbrella of several subareas. One of the first important subarea in AI is the machine learning. Here machines are learning from the data. So, it is this very important subset of AI. Here we give data to the machines and we train them. While training, they learn from the data and they make predictions. So without being any explicitly programmed. Here means your machine algorithm try to learn from the data. Once it learns, then it try to predict the future if for a given input. So supervised learning machines algorithms, they are basically trained on the data. So we have several techniques here, supervised learning techniques, where algorithms trained on labeled data. Labeled data means we can easily classify output, input and output. Suppose play a game, yes or no. Yes is a yes or no, or they are called as a labels. So if you see some rows with the same data, and by learning those things, your algorithm learns for a new record, it can say whether I have to play yes or no, like data is labeled. Second one, here in supervised generally perform regression and classification, where we identify the relationship between variables, and we so in classification we try to assign a particular class to the given data item, to which class this particular record belongs. Now this is supervised learning. Second technique we apply here, unsupervised learning. Generally here we perform cluster things. So where algorithms learn from unlabeled data, means data is not labeled. It has to identify the patterns and structures within the data. Next kind of reinforcement, next algorithm, reinforcement learning. Reinforcement learning is to achieve based on examples, learning from examples. So previously by looking at the examples, we achieve we learn the things and we try to achieve a goal. So semi-supervised is like a both hybrid approach of both labeled and unlabeled data. Next sub area in AI is computer vision. So computer vision is like a like eye to our humans. Here these AI devices, algorithms, they use this concept, vision concept, to identify and understand the objects in the images and videos. So whatever, how a human capabilities of vision, they are all mimicked in this computer vision. So these algorithms are trained on massive amounts of visual data. We have several applications of computer vision, like detecting defects, metrology, intruder detection, assembly verification, screen readers, OCRs, and robotics. So it is a main sub area of AI. Next sub area, expert systems. Expert systems, they work in a specialized domain. In a particular domain, there is a lot of knowledge is involved in that domain. Suppose if we take a medical field, a lot of knowledge in that medicine is available. So a doctor who practiced for years and years, he know how to give the prescription to patients. So in his absence, whatever expertise he achieved throughout his life, he cannot deliver. So such times what we do, rather than wasting his knowledge, we take a capture and in a knowledge acquisition. It is only one area of medicine. We apply in many domain specific application. Knowledge and rules of the knowledge, we take it. If somebody queries us, we pick it from the knowledge and we apply the rules and we give answers to the user. This is also very popular sub area of AI. Next important sub area, speech processing. Speech processing basically understand, analyze and generate human speech. So we see the application of this automatic speech recognition in our day-to-day life in many applications, where a voice is recognized by our system. It processes the commands that we have given and it performs the actions. I said some examples of Alexa and Assistant. Next important area, natural language processing. Natural language processing is also an important field of computer science, specifically, and a subfield of artificial intelligence. Make computer understand human language, because here intelligent machine means it has to communicate with other agents, means other computer programs or other machines. It has to communicate, it has to use some language, and communication, while communication it has to understand what others they said. So these natural language processing algorithms, they process the language instructions. They know how language works, analyze and process the text and voice data. So it is a very, it's not a small sub area, it has many application in many areas. We see many banking applications, websites, if you go you see chatbots. If you open our email, we have email filtering. So suppose some people, they travel people, they change areas, they translate language, they take the help of language translators. So sometimes sentiment analysis, we use this in our communications. Predictive texts, text summarizations, smart assistants and automated essay scorings. These many applications, they use natural language as their core part. And last one, you have a deep learning is another important sub area where we use the concept of neural networks. Neural networks are like a bunch of neurons that are linked together. They mimic the human brain neurons. They store the data and process the data, and they simulate complex decision power of a human brain. So they try to mimic exactly how a human brain works. We have many applications of deep learning in our real life. Image recognition, natural language processing, autonomous vehicles like self-driving cars. They identify the obstructions while driving whatever is on the way. How to take a decision in which direction I should move a vehicle. So that is processed automatically by these deep learning. They are trained, those trained algorithms on massive amounts of data. They take the decisions, and we have applications in healthcare for diagnosing and predicting the different diseases, recommendation systems. So neural networks concept is is a very now it's a very popular concept. From AI uses these neural networks in nowadays in many applications, and we have one fraud detection and virtual assistants. These are some applications of neural networks. So all these sub areas, they make AI as one big subject where every sub area has its own importance. So in next upcoming sessions we will learn about these things one by one. Thank you.